Good morning, class. So this will be a shorter lesson. As you know, you have written a test. Tomorrow we will look at the solution to that test you have written. Okay. So we are busy with the analytical geometry. The analytical geometry, you had homework on page, on exercise 11.2. Is that correct? Right, you had to apply the distance formula. Not so?
Yes, sir.
Any issues with number 1? Any issues with number 1? This is exercise 11.2 and this was on page 244. Any problems with number 1? No. So you had to do everything in number 1. First column. Okay, so you do for me the second column in number 1. Number 2, any issues there? Again, you have to do every alternate sum. Okay? Just hope you're not just saying you did it and you didn't do it. So this is your easy marks in the exam. And you won't figure it out in the exam. You'd have to do a couple of sums before you understand how to use this formula. So no problem here either. Then you have to go on to number 3. Number 3 says determine the value of x and y. The distance from the origin is 5. Any problems here? Yes. Which question? A. Why not just read now? So here we are told that the distance, so if you got the distance from the origin is 5. So if you look at a line basically, if it's from the origin, the coordinates is 0 and 0, not so, and the length is 5 to x and y, x and minus 3. Okay, so what we do, distance formula. So the distance formula is going to be the square root of x1, no, x2 minus, the formula you guys using are xb minus xa, no? Squared plus yb minus ya squared. So if you make this the first point, so that make this xa, ya, xb, yb. If we had in turn made this xa and xb and yb, then this would be xa and ya in that order. So that would be the square root of, what's the distance of this line? 5 xb, which is 0, minus x squared, plus 0 minus 3 squared. So to get rid of the square root, I'm going to square both sides. So that's going to give us 25 is equal to x minus 0 squared is negative x squared, which is x squared. 3 squared is 9. You take it over, becomes negative 9. Not so? So x squared is equal to 25 minus 9, which is 16. So what do I do now? Square root. If I introduce square root, what must I not forget? Plus minus. So x is equal to plus minus 4. Okay? So if you substitute, if you use xa to be 4 or minus 4, you will see you'll get the distance of 5. Any issues with C? Huh? E? Any issues there? No? So our work is going to be B and D. B and D is for homework tomorrow. Number 4. In number 4, in number 4 we have A, which is negative 1 and 1, B, which is 1 and 3, and C, which is 3 and 5 or 3 points in a line. With 3 points lying in a line, we also call that collinear, which means to say they all lie on the same line. Okay? So make a note thing that points that lies on the same line is also called collinear. Collinear points. Here, collinear. Collinear means to say that they all lie on the same line. Okay. The question says calculate the length of AB, AC and BC. What did you guys get for AB? What do you guys get for the line for AB? Didn't I ask you to do this one? Did I ask you to do number 4? What? So what is the length of AB? Oh God. Nobody did this question. It's a very good question, it's an exam type question. So you guys didn't do number, did I ask you to do 5? No, 5 is homework. Did I ask you to do 6? Huh? 6 is homework. 7? 8? 4. So in question 6 they say the question was, the question in 6 is show that triangle ABC is a right angle triangle. So when you're going to answer number 6, since we are busy with distance, you're going to work out the length of AB, the length of BC, and the length of AC. Where do you think the 90 degrees will lie? At B. Not so it looks like it's at B. Okay? So if you get to show that question, then that means to say it is a right angle triangle. Okay? So in right angle triangles, what do we know? What can we apply? Pythagoras. Pythagoras can be applied in right angle triangles. So once you have gotten those lengths, you got the length of AB, you worked out the length of BC, and you worked out the length of AC. You do all those calculations. Then you see that the hypotenuse squared would have been AC squared would have been equal to AB squared plus BC squared. Not so. So you got AC squared, you substitute that in and you square it. Then you got AB squared, you substitute that in, you square it. And BC's value, which you'll get from here, you also square it. If AC squared's value or answer is equal to AB squared plus BC squared, then that means to say that this is a right angle triangle. If it's not equal, then you rearrange first to see what is the longer side. Make the longer side first in the subject of the formula, that's important. No? If that doesn't work, then it is not a right angle triangle. Okay? So please do that for as part of your homework. If you look at number 7. In question 7 it says prove that quadrilateral. So what's a quadrilateral? A four-sided figure. Prove that the quadrilateral WX, Y, Z is a parallelogram. So what are the properties of a parallelogram? There's 4. No? Opposite sides are equal. Opposite sides are parallel. Two pairs of opposite are equal. Two pairs of opposite sides are parallel. The angles bisect each other. Opposite angles are equal. And also to prove a parallelogram, we can prove the fact that one pair of opposite sides are equal and parallel. If we can do that, we've done the job. So here, at this point we have worked out the distance formula. Not so we're working with the distance formula. So you work out the distance of Wx, the distance of xy, the distance of YZ, that thing on top, it's just to show distance, and the distance WZ. Okay? You will see that the distance of XZ, X is equal to YZ, and you'll see that those two lengths are equal. I'll show you the conclusion for that tomorrow if you do your homework, okay? And then the last question here is prove that PQRS is a parallelogram. Exactly the same as we did before. Okay? So this looks like a rectangle, but to prove it a rectangle you have to prove more than what we just did now. But that we'll get there when the question asks that. Okay? So to prove this is a parallelogram, it's exactly the same as we did. Okay? So now we're going to look at the coordinates of the midpoint of a line segment. Coordinates of a midpoint of a line segment. Okay, this is on page 248. Page 248. Now on page 248, since we only have like 6 minutes or 8 minutes left of this period, I want you guys to read through page 248. Okay? And you see how they derived the midpoint formula. Okay? So there's your midpoint formula. So we are told here that in the diagram, M, which is X and Y, is the midpoint of the line segment joining A, which is AX and YA, and B, which is XB and YB. The X coordinate of B and the Y coordinate of B. AK and MN are parallel to the X-axis, and KB and PM is parallel to the X-axis. Okay, using Euclidean geometry, they have proven how they landed up with this formula here. So I need you to write this formula down, which is the midpoint of XY. The midpoint, which is this point here, XY is equal to XA plus XB over 2 and YA plus YB over 2. That's the formula there. Okay. Please take your assignments out, okay? I'll collect your assignments now. Okay. So example 1 on page 249, we are asked to calculate the midpoint of line segment joining A, which is -1 and -1, and B, which is -3 and 8. So if we now put that on a Cartesian plane, okay, that's -1, -1 there, which is A, and B, which is -3 and 8. Let's put B, -3 and 8 here. So they want to know what is the value of that line. Okay. I think if we take out, let's check here. Take out the proper Cartesian plane. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so -1 and -1. Then it makes make that A, and -3. Sorry, is there, and so that's a 6, 7, 8. So that's approximation. Okay. Yes?
Sorry to interrupt. I was wondering how much time your vector possessing?
5 minutes. So you draw this line going through like that. So the midpoint is approximately here. Not so. It's a bit higher. But now you see because this point is a bit out, man. So it doesn't give you us the exact point, okay, but I would suspect it's around about here, okay. Can you see that? So the question says calculate the midpoint of a line segment joining A, which is -1 and -1, and B, which is -3 and 8. So for the midpoint of AB, okay, well, what's our formula? XA plus XB over 2, YA plus YB over 2. Okay. So it's XA plus XB over 2, YA plus YB over 2. Please memorize the formula. And every time you do this calculation, write down the formula. In turn, you will start remembering it. Okay. So again, if this is XA, then this will be YA. This should be, of course, XB and YB. So the midpoint would be what? What is XA? -1 plus -3 over 2. YA, -1 plus 8 over 2. So what's -1 plus -3? -4 plus 2? -4 divided by 2? -2. And -1 plus 8? 7. 7 divided by 2? 7 over 2 or 3.5. So if I put that onto this diagram here, you'll see here's 2. Okay, and 3.5 is approximately there. Can you see that, people? So this has to come over a bit. And then, but as I said, this diagram is not drawn to scale. It's because of this is being out here, and this value of B is out a bit. Okay, but if I draw this, you will see that for the midpoint it would have lied exactly on that coordinate. Okay. Let's look at another example. Example 2 on the same page, 249. So in example 2 on page 249, we are asked to determine the value of x and y if c, which is negative 1 and negative 2, is the midpoint. What do you notice now? The midpoint is given. Can you see that, people? The previous sum, you had to calculate the midpoint. Here, the midpoint is given. So I'm not going to draw it again on the axis. So it's going to be negative 1, negative 2. So this is basically what the line is going to be. Okay, so C is negative 1 and negative 2. Determine the values of x and y if C is negative 1 and negative 2 is the midpoint. So now, alright, so C is negative 1, negative 2 is the midpoint of line joining D, which is negative 3, negative 4, and E, which is x and y. Okay, so remember this is, EC is now the midpoint. Not so? C is now the midpoint. So what would this point here be? This would be x, D, y, D. Remember, this is the x midpoint and y midpoint. Not so. This would be x, E, and y, E. You all agree with that? So if we do the substitution, we know that the midpoint, which is x and y, would give us, in this case, x, D, plus xe divided by 2 and yd plus ye divided by 2. You all agree with that? Coming back to the formula here. You see that? The midpoint of xy, that point xy is equal to xa plus xb over 2, ya plus yb over 2. Now we have D and E. Can you see that difference here, people? So if we do the substitution, what would it read? The midpoint of xy would be what? Negative 1. Negative 2 should give us what? xd. Negative 3 plus x over 2. And negative 4 plus y over 2. Can you see that, people? So now, you see this negative 3 plus x over 2 is equal to what? Equal to? Negative 1. So you say minus 3 plus x over 2 is equal to negative 1. So what do I do now? Cross multiply. Negative 3 times x plus x times 1, negative 3 plus x equals 2 times negative 1, negative 2. So x is equal to, take it over the equal sign, it's negative 2 plus 3, which is 1. Okay? Then, we have negative 4 plus y over 2 must be equal to what? Negative 2. Can you see that? So that is going to be negative 4 plus y over 2 is negative 2. You cross multiply. So negative 4 plus y equals 2 times negative 2 is negative 4. So y is equal to negative 4 plus 4, which is 0. So there's your x value and there's your y value. If the question was to determine the coordinates of E, then you would have written, but it's not asked in this case. E would be 1N. Please go through the example again before you start your homework. Your homework is as follows. You're going to do for me out of exercise 11.3. You do number 1 and 2. Exercise 11.3, number 1 and number 2. Please have your assignment in your hand as you leave the class, okay? For those of you who are writing at the back, you do the same. You'll hand me your paper now, okay? Enjoy the rest of your day. Good morning, class. Zayman.